Yeah, so my name's Ben Stopford. Thank you all for coming. It's a pleasure to be here. I work at we've got a company called Confluent. We're one of the companies that sits behind Apache Kafka. We do like event streaming technology. And I'm going to talk to you a little bit about that today. I'm also got Rob Jackson with me. He's going to come on a bit later. But yeah, I'm kind of pushing 50 now. I've been doing this for a while. And kind of a proud member of Generation X. I think there's some other people that look like they might be part of Generation X out there in the audience today. And if you're part of Generation X, you're kind of like that last generation that really remembers the world before the internet, the world before mobile technology. Back when we had like televisions that were cathode ray tubes, and to change channel, you had to like walk up and turn that little dial the way, click, 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 click. And didn't matter too much because there was only like 3 channels to choose from. But yeah, it's a pretty big difference to what we see today. And I don't know if you have kids. I have kids that's about the age of my kids. And you show them a phone, they don't know what to do with it. And that actually makes quite a lot of sense because a phone, an old phone from the 80s, doesn't really bear any resemblance to what a phone is today. I mean, you can't text your friends, you can't check Facebook, you can't surf the internet, you can't play games, you can't watch movies on Netflix, you can't do any of these things. So the point is that the world is changing, and that's kind of obvious, I think. But probably the more interesting thing is that these changes seem really obvious in hindsight when you look back in time. But often these changes are not so visible at the time that they're happening because they sort of happen gradually and they kind of accumulate. And there's another change that's happening in business right now, which is actually really obvious if you stop and think about it, but maybe you don't always get the time to stop and think about it. And this change is the role that technology has in the businesses that we all work in. So primarily, it's a move from technology being a support function to technology being the actual business itself. So that seems a bit abstract. What does that mean? Well, what it really means is we used to build software which was designed to help us do our jobs better. We all do our job. It's like we build some software, we'd have to buy some software, makes us do our job better. So let's say we work in a bank, we're a trader, we have like a bunch of trading systems that help us trade better and manage bookings, etc., etc. These days, technology is the business. So increasingly, firms are building software which is not helping people do their jobs better, it's actually running core parts of the business. In some cases, the entire thing. And you can see this in every industry. I mean, look at who remembers Blockbuster? I mean, if you look at Blockbuster and you look at Netflix, it's kind of hard to believe that they were ever once competitors of one another. One is very clearly a bricks and mortar store, certainly has some technology running around there between those stores, but very different to the software, a software-defined business like Netflix. Likewise, banks have changed dramatically. No longer do people want to go physically into a branch in order to do stuff. They want to do it on their app. They just want to do it on their mobile phone. Banks are becoming software. Taxis are a wonderful example. Rather than a sort of taxi operator sat in his little office somewhere with an Excel spreadsheet or some basic piece of software that's going to manage the various different cars that he has on his books, we have things like Uber and Lyft that totally automate that process. So the whole business, in this case, is software. And it's done much more efficiently as a result. Cars are also becoming software. The home of mechanical engineering is increasingly the home of software engineering. Whether it's inside the cab, it's inside the engine, cars are now connected to the internet, etc. So we see this all over the place. We see it in transportation, we see it in retail, we see it in finance. So what enables this transformation? Well, it's really 4 things. I think there's like 4 fundamental themes which are enabling this transition to software-defined businesses. And they're cloud, machine learning, mobile, and data in motion. So clouds helps us rethink data centers. That's kind of the main thing it does, but it also changes the pricing model. And that isn't just about what we buy, it's the fact that now, in today's world, you have access to a whole bunch of services in the cloud which you would never have been able to afford the capex or the time to build in the previous world. So it's really about that. It's about that pricing model and how much tooling you have available to you in this world. Machine learning helps us rethink decision making. If you want to automate a business, machine learning is a core part of that, right? We have to make decisions. There's always going to be people managing error paths, etc. But for a lot of these fundamentally software-defined businesses, they're interpreting the world and in some cases making decisions based on these machine learning models. Mobile's rethought the way that we do user experience. This is actually more about us. This is about the fact that we expect a unified user experience when we interact with a company. It has to all work on mobile. And finally, data in motion, which is the thing I want to talk about the most today, specifically. So what is data in motion? Well, there's a couple of ways to think about this. First thing is to think about the fact that the most recent data, how new a piece of data is actually pretty important to a business. If you're working on a one-day batch cycle, then your data is going to be a day old. Maybe that doesn't matter for some applications, but for many these days, many of these businesses, the data has to be available everywhere and it has to be available in real time. So you wouldn't blindly cross the street with traffic information that's 5 minutes old. Likewise, you want for a business to operate efficiently, it wants to have real-time data. And the best way to think about this from a technology change perspective is to think about the difference between data at rest and data in motion. Data at rest is what I think we're most familiar with. That's the database. Wonderful tool where you can save data, it will keep it safe for you. You can send it a question, and it will give you a very accurate answer in a way that there's no other way to do. But it kind of locks data up in one place. And what we're seeing today is this shift to not just having data at rest, but also having the same type of technology, the same type of technical infrastructure that's designed for data that moves around an organization. So these data in motion platforms move data from place to place. They allow that data to be translated into different forms. It allows you to react to events. They can do all these operations transactionally, much like a database can. And a good way to think about how these data in motion platforms are applied is to think about a central nervous system. So data in motion is a kind of central nervous system for today's enterprises. Something that sits at the heart of the enterprise and allows data makes data available throughout it instantaneously. And Confluent is the technology, the sort of primary technology that powers this, whether you're in the cloud, whether you're on-premise, it sits across your whole organization, wherever it might be placed. It's powered by Apache Kafka. So to get a real understanding of this, it's actually better to think about a use case. And one of my favorites is actually retail. And the reason retail is good is because we all do online shopping, right? So if you think about something like Amazon, Amazon is actually using data in motion. Every time you go to you want to buy something, maybe you want to buy a book, maybe you're buying, I don't know, a tablet. You go onto the page for where the tablet is, and you'll see there's a bunch of information about it. And there's a bunch of stuff that's actually personalized for you. There's some recommendations on there. Those have to be calculated in real time, some of them. Then there's also information like, Amazon can do same-day delivery. So if you're going to get same-day delivery on that particular item, that's going to pop up and give you that option. But to figure that out, Amazon actually has to know quite a lot of information. It has to know where you are. It has to know where its various different depots are. It needs to know whether that tablet is in stock in each one of those depots. It has to have information about the distribution network and whether or not they're going to be able to get that that tablet to you in time if you are to buy it, etc. And this is where data in motion becomes critical, because the software that sits behind Amazon is not just sitting on one server, as I'm sure you all well know. It's distributed across a whole bunch of different data centers. It's distributed, obviously, in the cloud. And it's a whole bunch of different services, much like this. So the order service and the inventory service and the shipping service and the reporting systems, they all have to be able to share data, and in this case, know about where the tablet's going to be, to know that they can ensure delivery on the promises that they're making on that website. And that is one of the core reasons you use Amazon. You use Amazon because you trust them to get you your item on Christmas Eve, by Christmas Day morning, or whatever it might be. So it's actually like a crucial part of the way that the business operates and the USP it offers to your customers. So data in motion is really a technology that enables this real-time movement of data through an organization. And it's a kind of a reimagining of messaging. So you can create these events. You can take them you can link them to databases, create events which can then be published around an organization. You can store those event streams inside the Confluent, inside Confluent Cloud, inside Kafka if you're using Kafka. You can process and analyze this data transactionally and in real time using stream processing tools. These typically, most of these use SQL these days, just like databases do, so it's really like a database for data in motion. So why is this of strategic importance? Well, there are a number of reasons for this, but the one that I think is most pressing is that companies have pretty complicated architectures. I mean, this is actually a reference architecture for a bank. If anyone works in a bank, they will almost certainly know that their architecture looks nothing like this. It's about 50 times more complicated. But architectures are increasingly complicated, and technology innovations actually tend to encourage decentralization for very good reasons. So things like microservices encourage us to have a greater number of services. They tend to be distributed. They tend to be running on a larger number of machines. Cloud, etc., also accentuates that. And the globalization of architectures makes it's even more so. You can be running in a variety of different regions. You can be running on different cloud providers. So companies are kind of torn in two directions. In one sense, they're getting pushed away from towards these like decentralized architectures, where this software that's starting to define their business is increasingly spread over a larger estate of servers, over a larger estate of teams. But in the other direction, customers want these unified user experiences. They want to have a single place that they can go to where the whole company doesn't appear like this very distributed architecture. It appears like as something that's like very joined up and a single unified thing. So what we're seeing the data architecture of organizations changing as a result of this. So rather than this the traditional monolithic approach where you have a single data warehouse, where all of your systems in the company feed back into this one data warehouse, we're starting to see trends like data mesh, which pushes towards decentralized architectures. Architectures where there isn't just one endpoint for data. Data actually sits in a mesh or inside a streaming platform, and as data in motion, and is made available to a whole variety of different applications and services, always all in real time. And the key part to this is making these data sets self-service. So I'm going to hand over to my good friend Rob Jackson from Nationwide, because they have like a great example use case of it around this. And I think this really helps to kind of solidify what we're talking about in something that's running in the world today.
Thank you very much, Ben. Hello? Yep. Great. Thank you very much. Thanks, Ben. That's really interesting. Just before I start talking about what we've been doing at Nationwide, I thought just to give you a little bit of context, I better explain who Nationwide are. So I'm Rob Jackson. I work for Nationwide Building Society. We're the world's largest building society with about 15 million members. A member means you're a customer of one of our banking products, current accounts, savings accounts, etc. But you're also a member, which means you get to vote for us. we were founded 135 years ago, and I think what the thing to take from that is we've got a lot of IT systems, some very old, some very new, and those systems need to interoperate. We announced a couple of years ago a big investment in technology of $4 billion over 5 years. We're a year or so into that, and that investment is around modernizing our landscape, and I'll be talking about that in a minute. And Confluent Kafka and the architecture I'm about to talk about is an important part of building that future. So why do we need to modernize, and why did we choose Kafka to help us modernize? So we've talked about digital distribution already. What that means specifically for us is we've seen a general uptrend in digital use over many years. Obviously, that's accelerated a lot over the last couple of years for obvious reasons. People who may have chosen to go into a branch in the past are now having to go online, so a big uplift in digital use. Open banking was regulation brought in by the banking regulators, which is about increasing competition in the banking market, making it easy for you to use things like aggregators to pull accounts, view accounts from different providers. So we have to provide a good reason to use nationwide systems. Why would you use a nationwide system when I can use something from an aggregator? Of course, non-traditional competition. There's companies like Amazon announced they were thinking about entering the business banking market, and other new bank startup. And the thing, I guess, with these newer players is they don't perhaps have the legacy of a company like Nationwide, who've been around for 130 odd years. And you all, of course, have, and I do, of course, have increased expectations in what we get from our banks. So you don't expect to apply for a loan, wait a few weeks, and then maybe hear the outcome of that. You want to apply for your loan, and you want to know straight away whether you've got that loan, and you want to see the money in your account and be able to transact on it straight away. So I guess I expect that. I guess you expect that. So what does that mean for us? Well, that all fed into our IT strategy, and the outcome of that was we started looking at technologies like Kafka to help modernize. So why did we choose Kafka, and what does it provide? Well, the first thing up here is near real-time data caches. So Kafka gives the ability to store, hold, and then allows us to take data to where it's needed and build pre-populated data caches. It's highly resilient, highly scalable, and so always on data where you need it. A key thing for us is events and stream processing. So this you might call liberating data from some of our older systems and allowing them to participate in a world of events and data in motion, and cloud migration, a really important thing for us. So you saw a diagram a minute ago from Ben. This is probably from a similar era. This is a SOA reference architecture from 2012. And when I look at that, I see quite a lot of layers, and I don't really like layers. And on the right here is a very, very simplified view of what that SOA reference architecture might turn into. So the reason why I'm showing you this is another reason why we felt we needed to modernize. So if you think about a transaction, you've got your banking app at the top here, and to get to the data, which is all the way down here, you've got to go through an API gateway owned by a team. You go through some channel services, which is probably another team. Then you've got the middleware team. You've got some other technology like an enterprise service bus or some process engine, and that might call some CRUD services that the platform team created, and then finally you get to your data. And then you start thinking about how do I add new data to this layer, and how do I expose it? And I've got to coordinate that change with a whole bunch of teams. And then I start thinking about I want to do agile, and I want to create feature teams and Conway's law and reverse Conway's law. And I think what I see from this is a really complex way of getting data at rest. It doesn't give me events, and it doesn't really make it that easy for me to go to cloud. So this is kind of one of the problems we were trying to solve with Kafka. So we internally called this our speed layer, but I think I said I didn't like layers, so I'm talking about it. Today I just want to talk about data distribution and events. And what we introduced was, on the left-hand side, you can see we've got a number of systems, and that could be any number. But for us, we started with some of our mainframe applications, our traditional systems of record, like our customer master, our core banking systems, databases, and even files. And what we do is when a change is written to that mainframe, so a financial transaction or a customer change, we capture that change using software like change data capture, and we get that into Kafka as close to real time as we possibly can. Similarly, we could be using things like Kafka connectors on databases, which look at things like the transaction log, or you can even ingest files. But fundamentally, we get that into Kafka as quickly as we can. From there, we use stream processing to process that data, aggregate it, break down those data silos, and simplify that data. And from there, we create processed topics. And the purpose of those processed topics is to make it easier to get that data to where you need it in the structure and the format that you need it. So for us, we started with materializing data into MongoDB on-prem. We created a MongoDB cluster, and that allows us to create MongoDB collections with exactly the data that a particular application needs. So highly optimized collections for a particular purpose. Of course, that data can go into the cloud as well, and I'll come on to that in a second. A key one is building applications that consume events directly. So instead of querying data at rest, the interesting thing there for us is we are consuming events natively. So a customer we've just got a new customer, or they changed their address, or something has changed about them, and applications are interested in those changes and can aggregate or join events from different systems and learn interesting things about them. So we can do things like push notifications to you. Your spending patterns have looked different this month, or something looks unusual, and that might be some kind of fraud kind of alert. And the key thing there is, as those applications generate and derive events, they go back into Kafka for other applications to consume. And then finally, those streams of change data that are coming out of databases and getting processed in Kafka, then we can sync them into things like Hadoop or even an S3 bucket in Amazon, so we can do advanced analytics. And when we generate analytical insights off that data, and again, that can feed back into Kafka, where our applications can consume it. So what does this mean for us? So Confluent Kafka has become our streaming platform with enterprise event hubs, and we're trying to adopt that as broadly as we can. We get to source events from our existing systems. So I said we've been around for 134 years. None of our systems are quite that old, but some of them are pretty aged. And we get events from those systems, and we get the benefits from that. Event-driven use cases where we build applications natively to both consume and produce events is on the increase. This kind of box up here where I said MongoDB, that could be any database of choice for querying that data, but we get to produce APIs against that data in the way that we want it for that application. So it could be things like GraphQL instead of some of our older protocols like SOAP. And by having those data caches, we're actually moving significant workloads from some of our back-end mainframe systems, which of course we can scale and are highly available and highly resilient. But we can take that workload, move it off, and potentially save money from that. So I don't think it'd be fair for me to talk about this architecture without talking about some of the challenges that we've had. And I think some people like the challenges more than the architecture, or hearing about the challenges. So the first challenge was, how do we replicate data and how do we enable cloud adoption? Before you talk about how do you replicate data, first of all, you need to think about, should you replicate data, and when should you replicate data or distribute it? Because there are benefits. It's not the answer to every problem, and sometimes it's better to centralize it. And then, of course, people have different views on when you should centralize and when you should distribute, depending on their role in the organization. If you're in a governance role, you're kind of quite comfortable with everything sitting in a single database, and you're probably less comfortable with distributing that data. And then when you think about, yes, I should distribute data, you then think about, how do I distribute it? If I've materialized data into a MongoDB or a SQL Server on-prem, I can stretch those clusters around data centers and even into the cloud. Should I do it that way? Or do I replicate at the Kafka level? Or do I do things like change streams, which are ways of getting databases to emit events? We tended to choose Kafka to do it. And the reason we chose Kafka replication is because it's not opinionated about what you do with that data. You replicate those process topics into the cloud, and then you can materialize or sync however you want to. Sync it into a Redis cache or Elasticache or Neo4j or MongoDB or HDFS. Data complexity. Our systems tend to be built around relational databases and highly normalized. Taking highly normalized data that often is database level changes, so there's insert and update operations on databases going into Kafka, you need to do a significant amount of streams processing to make that turn those database level changes into meaningful events. And going from relational schemas into collections, these were all challenges in the world of data modeling. So non-functionals, we're looking at some of our largest systems in this architecture, so 15 billion transactions, 100,000 transactions a second, lots of reads and writes. These were, big systems for us. Technologies like Kafka, MongoDB, and so on, they're certainly proven at internet scales, and they were up to it, but it was challenging for us. And happy path, if you're building caches, you've got to look at data congruency. Is my data accurate? These are all challenges for us. And maybe the most important one, or the key challenge for us, is around when you start to introduce data in motion and events, are new technologies, new ways of thinking. So I've already talked about centralization versus distribution, but you've got things like streams processing, stateful joins, quite a different way of processing data than SQL statements. And of course, going from a strong consistency model, where everything is centralized, you start distributing data. It's an eventual consistency model. So we had a target of keeping that data pipeline latency as low as possible, and it's turned out to be around about a second. But it's still an eventual consistency model, and you need to cater for that. So with that, thank you very much. And I think, Benny, have you got anything else you wanted to add? No? Okay, well, thank you very much. Enjoy the rest of your day.